when we're looking at transformations of y equals 1 over x, this is the first one we already talked about briefly. The transformation here is a vertical stretch by a factor of 4. So if you look at a few points, let's pick these two to start with. At 1, 1, and at -1, -1, where did those points go when you transform them? 1, 4, and -1, -4. Right. Because it's just the mapping rule there that we talked about, xy maps to x and 4y. So you have these points at 1, 4, and at -1, -4 for the new graph. And then it basically, it looks fairly similar, right, to the original. It's stretched. So you could pick a few more points and transform them. But you get a graph, it's hard to draw in here because it's always kind of squiggly, but something like that, right? Same general shape, but going through those points. And if you picked a few more points or used your graphing calculator, you'd have something a little better than that. But the important thing here is kind of picking out the transformations. This is another one that you did. This was D. What are the transformations here? Vertical stretch by a factor of 2. So a horizontal translation of 3 units to the right and a vertical translation 2 units up. Those are the 3 transformations, and then you can draw the graph. So you already figured out that if we're going to transform y equals 1 over x, this y equals a times 1 over x minus h plus k is kind of what you want it to look like, and then you can tell what the transformations are. But if we look at y equals 1 minus 2x over x, we can't tell what the transformations are. So we need to change the way that this one looks. This one's pretty simple to change. We just need to split it actually into 2 fractions. So instead of 1 minus 2x over x, I'm going to do 1 over x minus 2x over x. That's the same thing, right? I just put each term in the numerator over the denominator by itself. And then what can I do to simplify it? Cancel the x's. So this is just y equals 1 over x minus 2. And now you can say that there's a vertical translation 2 units down, and then draw the new graph. So that one's pretty simple. Just split the fraction and then simplify. That works when you have only one term in the denominator. So the denominator here was just x. But if you look in example 8, the rest of them don't have only one term in the denominator. So we're not going to be able to split it that way. We need another kind of method, and that's what we're going to do now. And we're going to start with this one. What we're going to do with this to get it into that transformational form is a process that I think of as kind of similar to completing the square with a quadratic. If you remember taking a quadratic function and changing it from general or standard form into vertex form, you had to do this process of completing the square where you kind of add in this random term to make things work. And that's what we're going to do here. For things to cancel out in the end, which is what happened in the previous one, we need to have an x minus 5 on the top and the bottom. So what I'm going to do is just put in an x minus 5 in place of the x. But I put in that x minus 5 in place of an x. It's not really okay to do that, right? I added in an extra negative 5. So then I need to take that off as well, and I'm going to do that by adding 5. If you look at this expression, it's equivalent to the expression above. Do you agree? Are these two things equal? Yeah, because all I did was subtracted a 5 and added a 5. So it's a zero pair. I didn't change its value. And so it's okay to do that because it's still the same expression. It just looks a little different. The reason that I did that is because I want an x minus 5. So actually now I'm going to separate that negative 5 and positive 5. All I want in this bracket is an x minus 5. So what do I do with the plus 5? Multiply it by negative 6 to get it out. And when I do that, it becomes a negative 30 out there. So now I'm going to simplify this a little bit more. I have 33 minus 30, which is just 3 minus 6 times x minus 5. And that's all over x minus 5, but I'm actually going to put each term separately over x minus 5. When I simplify that a little bit more, this one is going to stay as a 3 over x minus 5, but the other one just turns into a negative 6. Then I could graph it because I can see that we have a vertical translation, a vertical stretch by a factor of 3, a horizontal translation of 5 units to the right, and a vertical translation of 6 units down.